Hi guys, welcome to another video. We are still continuing with Cauchy-Riemann equations. The Cauchy-Riemann equations, the last time we dealt the Cauchy-Riemann equations in polar form. So today we are doing an example which is different from what we expected, but we got it from the textbook. And let us just go through it. Thank you guys for the support we are getting so far. Today is the last lecture series on the Cauchy-Riemann equations, but we'll be continuing with Cauchy-Riemann. It doesn't mean that you are not gonna see it anymore, but we're just saying that it is the last example that we're doing on Cauchy-Riemann equations. So the question we have there, we say that we should use UR is equals to UX cos of theta plus UY sine of theta, and U theta is equals to negative UX R sine of theta, and to show that this is true and that is true. Okay, so if you're given two equations and you need two unknowns, then therefore that is a simultaneous equation. So let us have that solution. Okay. Let us take this one as equation 1, and let us take this as equation 2. Okay, so from equation 1 we can just make UX the subject of the formula. So if you make UX the subject of the formula, it's like me subtracting this and dividing by that. So we have UR minus UY sine of theta divided by cos of theta. Okay, so we take this equation, we substitute it in equation 2, and yeah, so let us see. So our U theta will be equals to negative. Now when we see UX, we substitute this UR minus UY sine of theta divided by cos of theta. Okay, and then we have R sine of theta plus UY R cos of theta. Okay, so practically what we're gonna have is this one, because now we have only UY. Now let us multiply each and every term by cos of theta, because I want to do away with these fractions. So each and every term can have UR minus UY sine of theta. Okay, so this one stays here because it's part of this term. Okay, plus UY R cos squared theta, okay, so we have multiplied each and every term with cos. The next part that we're going to do is, let us expand this, okay, and do away with the brackets. So we have well, you can just multiply by negative R sine of theta. So we have negative U R sine of theta plus U Y R sine squared of theta plus UY R cos squared of theta. Okay, so we can see that these terms are with respect to UY. So let us have this one on the side. So we have this, we're gonna have U theta cos of theta plus UR R sine of theta is equals to, now if you take out UY here, actually UY R, so we have sine squared plus cos squared, which is 1. So we can clearly see that UY is equals to, now we have U theta cos of theta, and this is divided by R, plus UR R sine of theta, this is divided by R. Then our UY is equals to U theta cos of theta divided by R, plus, now this and then they go to town, UR sine of theta. Okay, so this is the proof of this one. Okay, now Okay, I've ran out of space. Let me get. Now we have proven that one. We have found our value of uy. Now let us find our ux value. Now remember, what is our ux value? Is this one that we have here. So we just substitute uy. Okay, just substitute uy. So let us do that. So our ux, our partial of u with respect to x was given by ur minus uy sine of theta and the whole thing divided by cos of theta. So me, I don't like working hard, guys, okay? So I'll just try to manipulate it as early as possible. Is equals to ur minus uy sine of theta. Okay, so actually I just want ux, so I don't need to do this. I nearly made uy the subject of the formula again. Sorry. ux, so this is just direct substitution. That's cool. So what we have here is minus, now we had u theta cos of theta divided by r. Yes, that's what we were supposed to get. Oh yes, and then plus ur sine of theta, and the whole thing is multiplied by sine of theta, and the whole term is divided by cos of theta. Okay, so what we're going to have here is our ux will be equals to okay, there's nothing much we can do. We can just write it as ur minus u theta multiplied by sine of theta, and then we have cos of theta divided by r, and then we have plus, now we have ur sine squared of theta. Okay, so we have that. So the whole thing is divided by cos of theta. Okay, cos of theta. Now our ux, why am I saying ux? Our ux is equals to we'll take out ur, make it the subject of the formula. So when we take out ur, what we have is, this is subtraction now, so we're gonna have 1 minus sine squared of theta, and then this is going to be minus where is it, u theta sine theta cos theta divided by r, and everything is divided by cos of theta, and we know that this is cos squared. Okay, so our ux is equals to ur cos squared of theta minus u theta sine theta cos theta divided by r, and everything divided by cos of theta. So each term divided by cos, it will give us simply that ux is equals to ur cos of theta, because it goes there, minus u theta, and we're gonna have sine of theta divided by r, which is the second part that we needed to. Okay, so the second part that, actually this one. So we just proved this one, and at first we proved this one, then therefore we found our solutions. There's our uy, and then here is our ux. Okay, so guys, without wasting any more of your time, guys, thank you very much for watching this video. If you came this far, please do hit that like button, as it helps with the algorithm of our growth. And guys, thank you very much again for being with us today. We hope to see you on the next one. Thank you.